Hello, today I'm going to take you through the illustrative math geometry lesson from Unit 1, Lesson 7, Constructing a Square. So we'll start at 7.2, it's cool to be square. And I'm going to do this rather quickly since you'll do it in class as well. But the first thing I'm going to do is extend line segment AB so that it's actually a line that goes on forever in both directions. Now, when I think about a square has 4 congruent sides and 4 right angles. So since we just made perpendicular lines in the last lesson and those form right angles, I'm going to start with that concept. I'm going to try, since I know AB is supposed to be a side length, to figure out how to make a line through point A that is perpendicular to the existing line. So if you remember from the last lesson, we started that with a circle of any size. We marked the 2 intersection points. And then we created the perpendicular bisector. So 2 overlapping circles of the same size centered at either point D or E. Find the intersection points. We're going to do this real quick. Draw the line, which is the perpendicular bisector of DE, which by definition has to pass through A because that's equidistant from points D and E. And by definition, since it's perpendicular, it makes a right angle at A. So we're part of the way there to our square. Now, a lot of times when we're making complicated constructions, it can help to hide some objects. So at this stage, I'm going to hide everything except for my original segment and line and my perpendicular line. Okay, great. I've got 1 extra point. I'll hide that real quick, and we'll move on. Now, I can sort of start to see my square coming together, but I'm going to need a perpendicular line at point B as well. So I'll repeat that same exact process. Make a circle, find the intersection points between the circle and the line, create the perpendicular bisector. By default, this is going to create a line that's perpendicular to the original line and passes through point B because it's equidistant from the 2 endpoints I and J. Okay, if I want to, I can hide a lot of that stuff. You can see already that if I don't hide it, I've got a lot going on, but you can see those 2 separate perpendicular bisector constructions kind of coming together here. So now I have, one more thing to hide. Now I have line segment AB and these 2 perpendicular lines, one at point A and one at point B. Now, if I can figure out where to close out the square, I should be done, right? So keep in mind that a square has to have all 4 sides congruent or equal in length. So what I can do now is use my circle. Way back in the beginning of the course, we learned that the radius is always constant, meaning that the distance from the center of the circle to the edge is the same for any point along the circle. So if I make a circle centered at A that goes to point B, I can simply mark this intersection point up here, and that will lock in the same side length for AB and AM. So now I've found the 3rd point on my square. Well, to find the 4th point, I can do either the same thing from point M, make another circle of the same size, or I can do the same thing from point B. So I'll just use the compass tool. I'll select A to B as the radius. I'll put that at point B, and then this last point up here should be the 4th point on my circle. On my square. So now when I construct this, I can connect these 4 dots. By construction, I know I've formed right angles at A and B, and I've formed congruent sides between A and B, A and M, and B and N. If you want to check that 4th side, if you're not convinced that that would be forced to be congruent, you can make another circle of the same size at point N, and you can see that it locks right into M. And there you go, you have your square. And if you wanted to really convince yourself that this was perpendicular to these original lines, you could create perpendicular bisectors and you would find that it would go right through MN. So we have our square. Now when you get down to 7.3, it'll challenge you a little bit, okay? The first part of 7.3 will just ask you to kind of create some circles, so we'll do it real quick. Circle centered at A with radius AD. A circle centered at C with radius CD. And then they want us to create the diagonal AC and write a conjecture about the diagonals. There's a lot of conjectures you can make about these diagonals, but if you look at what we've just done here, it looks like BD is a perpendicular bisector of AC. Okay, and now it says to label the intersection points. If you turn your head kind of sideways, it's a diagonal perpendicular bisector construction. And construct a circle centered at E with radius EB. And it says, how are the diagonals related to this circle? So let's get rid of all the other circles so we can see what's going on here. How are the diagonals related to that circle? And if you look at that, if this segment BD was the perpendicular bisector of AC, that means that these are perpendicular. And then if E is the center, and A, D, C, and B are all along the edge, that means that all of these segments here are the radius, which means that BD and AC are both the diameter. Okay, so what we know is that these are perpendicular and that they bisect each other. So now, if you wanted to create a square inscribed in a circle, we can actually do this really quickly using those conjectures. If I create a line that goes through my circle, and I find the two intersection points, that center of the circle is like the center of the circle up here, point E, okay? These 2 points here are going to be 2 of my points to make my square. And to make the other 2, I just need to make the perpendicular bisector and find where that intersects the circle. So let's see. Let's label our intersection points. So we're going off those conjectures about the diagonals being perpendicular and bisecting each other. Now, by definition here, if I've created the perpendicular bisector, these 2 diagonals are perpendicular, and by definition of a circle, all of these points are the same distance from the center. So we should be able to quickly construct our square with these 4 points. All right, thanks so much for joining me. I hope this clarified how to create a square and a square inscribed in a circle.